electrostatics, we will be looking at the electric potential due to the dipole. That is, what is the electric potential at a point P due to an electric dipole. For this, we are going to make some constructions. So let us just take a dipole AB with the minus q charge sitting on point A and plus q charge sitting on point B, and the distance or distance of separation between the two charges, let us take it as the d. That is, the length of the dipole is d, and let O be the point called midpoint of the dipole. Okay, and P is the point at which we have to find out the electric potential, and it is at a distance r from the midpoint of dipole. That is, the distance of the point P at which the potential has to be found out is at a distance r from the dipole. So now we are going to make a certain amount of assumptions and constructions. In this case, the basic construction would be to draw B dash perpendicular to OP. That is, I am going to take one perpendicular to OP from B, that is going to be B dash, and similarly from A also I am going to draw one perpendicular to OP by extending OP up till A dash. So OA dash and OB dash, these are going to be the base of the right angle triangles OA dash A and B dash O. Okay. So this is about your construction, and a small amount of assumption will be approximation we are actually making here. That is, the length of the dipole is negligibly so small as compared to the distance of the point at which the potential has to be found out from the dipole. That is, R is very much greater than D. That is, D is negligible compared to R in this case. So these are certain assumptions, and according to this diagram we can see that since it is a right angle triangle and this is the angle theta in both the triangles, so OB dash I can write it as OB cos theta, because OB is the hypotenuse multiplied by cos theta will give us the adjacent side. So here as well the adjacent side can be given as OA cos theta. So this is about your constructions and certain amount of approximations that we have made in this particular problem. Now let us go to the actual workout. We have to first find out what is AP and BP, that is, from A to P what is the distance, and from B to P what is the distance in terms of OP. I have to find it out. So to do this, we are going to use the assumption that AP is almost equal to A dash P. The reason is very simple, because R is very much greater as compared to D. That is, D is a very small value as compared to R. In such a case, I can safely assume that AP and A dash P, that is, AP and A dash P, these two are almost one and the same. So in such a case, I can write A dash P, that is, A dash P can be written as OP plus OA or OA dash. Right? So OP plus OA dash we have taken, and OP I write it as it is. We can see that OA dash is nothing but OA cos theta I have substituted. And what is OA cos theta? OA is nothing but half of the dipole, which means OA is equal to D by 2. In the similar manner, OB also will be equal to D by 2 here. So I am going to substitute it over here. That is, for OB we are going to substitute. So BP is equal to AP is equal to OP plus OA cos theta. I can write it as R plus D by 2 cos theta. So next we go to the BP, that is, from B, what is the distance from B to P? That is going to be BP equals to B dash P equal to OP minus OB dash. You can see here, this is OP and this is your B dash P, right? So OP minus OB dash will give me B dash P, or I can safely say that it is equal to BP, as R is very much greater than D, right? So using all these assumptions, approximations, and using the diagram, we get the formula for BP, that is, the distance from B to P as R minus D by 2 cos theta. We are going to take it as equation number 2. Now, the electric potential at point P due to charge minus Q, which is at point A, will be given by VA is equal to minus 1 by 4 pi epsilon naught into q by AP. Now why this minus sign? The negative sign, it actually appears due to the fact that the charge at A is negative. Unlike in case of your electrostatic force and electric field, here the potential will take up the negative or the positive values depending on which charge exists, and due to which charge we have to find out the electric potential at a given point. So here, since V is dependent on Q, magnitude as well as its sign, it will take up a negative value. So VA is equal to minus 1 by 4 pi epsilon naught into Q by AP. Now AP, I have already got the value, that is R plus B by 2 cos theta. Same thing I will substitute here. So that equation becomes VA is equal to 1 by 4 pi epsilon naught into Q divided by R plus B by 2 cos theta. So next we go to the potential at point P due to the charge Q, that is plus Q at point P. So it will be equal to 1 by 4 pi epsilon naught into Q divided by BP, right? So it is going to be BP. So BP I already have found out from equation 2 that it is R minus D by 2 cos theta. So 1 by 4 pi epsilon naught into Q divided by R minus D by 2 cos theta. This will be equation number 4. Now we know that the electric potential is a scalar quantity. So we can just take the algebraic sum of the two potentials in order to find the net potential at point P. So net potential at point P, V is equal to VB plus VA. So what is VB? VB is nothing but 1 by 4 pi epsilon naught into Q by R minus D by 2 cos theta, and VA is minus 1 by 4 pi epsilon naught into Q divided by R plus D by 2 cos theta. I am going to take the common 1 by 4 pi epsilon naught outside, and Q by R minus D by 2 cos theta minus Q by R plus D by R plus D by 2 cos theta remains inside the bracket. Q also I can take it out, and then I will take the LCM. When I take the LCM comes out to be R square minus D square by 4 cos square theta. Using the formula A minus B into A plus B equals to A square minus B square, and I get R plus D by 2 cos theta minus R plus D by 2 cos theta in the numerator. So here R and minus R gets cancelled off, and we have D by 2 cos theta plus D by 2 cos theta giving us D cos theta. 2 times D by 2 cos theta will give us 2 and 2 gets cancelled, and we have D cos theta, and denominator is R square minus D square by 4 cos square theta. We will write it as it is. And now we have an assumption which we had already made, that this R is very much greater as compared to the length of the dipole. So in which case this D square cos square theta, I can as well ignore this because it's a negligible quantity. Subtracting a negligible quantity from a larger quantity, I can safely assume that R square is almost equal to R square minus D square by 4 cos square theta. This I can safely assume, as R is very much greater than D, and so I get the equation V is equal to 1 by 4 pi epsilon naught into QD cos theta by R square. Now this Q into D is nothing but the electric dipole moment. So when I substitute, we get the final expression for the potential, that is V is equal to 1 by 4 pi epsilon naught into P cos theta by R square. Now in this case, we can see that this particular expression can also be written in the vector form, in the form of a dot product, that is, which is V is equal to 1 by 4 pi epsilon naught into P bar dot R cap divided by R square. Because P into cos theta into, I can write it as 1 here, that is representing the magnitude of this unit vector. So we can see that P bar dot R cap will be P cap dot P cap dot 1 R cap. So this will be P cos theta into 1. So I can write it like this, and we can see that if this point P, that is the point at which the electric potential has to be found out, if it lies on the axis of the electric dipole moment, then theta becomes either 0 or 180 degree. In such a case, we get the expression to be V is equal to plus or minus 1 by 4 pi epsilon naught into P by R square. So this is about your electric potential due to an electric dipole. So it's a very important point, Remember one thing, potential is a vector quantity, so we'll get a dot product over here. So this is about your electric potential due to an electric dipole. Thank you.